Okay. Trimmed mean, the name says it all. Okay, trimmed mean. It deals with outliers, right? So the main reason that we're going to want to trim is for the outliers. And I'm just going to draw your attention to this little side note here. That is a good summary of trimmed mean. It is calculated on page 29. It is calculated, it is the mean, calculated by what? What does disregarding mean? Not take it into account, yeah? An equal number of data points from both ends of the range. Okay? That's what the trimmed mean is doing. Because, watch this, an outlier can significantly be different from the general trend. Okay? And to account for this, the trimmed mean may be more representative of the measures of central tendency. Okay? And here's where I'm going to go back to orange. Omitting an equal number of values from the upper and lower ends. Okay? That is what trimmed mean is doing. And I don't know, the best example that I can think of, but then I realize that not a lot of you watch the Olympics. But I don't know if have you ever seen like a diver? I like the diving competitions the most because I could never do that, and I was like, wow. I don't know if you ever look at the scores at the bottom of the screen. There's a bunch of judges that give it a score, and they'll trim the highest and the lowest. I don't know if you've ever noticed that. So that's to avoid bias. So let's say that it's an American athlete and there's a Russian judge. I don't know why I'm using that example. I should probably not be using it. But right now things are kind of tense, right? So it could be that the judge might be biased towards the other athlete and give it a lower score. So to account for that, trimmed mean is introduced. Like we're getting rid of the lowest but also the highest. Okay? So in this particular case, which two scores would be eliminated? 2 and 10, yes. We get rid of that one. And you also get rid of that one. So that's the thing with trimmed mean. You don't just get rid of the lowest or the highest. You get rid of the lowest and the highest. Okay? Okay, so let's keep going. And I will ask you to highlight this. It's a little trimmed mean. This is not good, but I'm going to try anyways. It's there for greater accuracy. Greater accuracy. Can you please get rid of the 10% trimmed mean? That's a different course. We're not going to worry about that. I just wanted this image here. If you trim the mean, see the scissors there? You gotta make sure, listen carefully to this part. You don't have to arrange it. You don't have to, but you have to make sure that you find the lowest and the highest and omit them in your calculation. So it's almost like you imagine they were never there and you just find the average of what remains. That's what it is, okay? It is more trimmed mean is more representative. It can be done in the Olympics. Sometimes they look at teachers and they say they don't, but I know they do. Exam marks don't matter, right? But then we always get a printout of our exam marks. I'm like, so you are looking at them, right? So it could be that, right, a student may have been sick. Like if you're sick that day, you get a 0 on it, right? And that affects the average. So it would be probably better to go with a trimmed mean in that situation. I will leave this for now. I will leave this page for a little later because I want you to practice how to calculate it first, okay? So let's go over to page 32. And the blank page on 31, I'm going to use that as well. So on page 32, the data contains the following values. Okay, and we're just going to assume, let's assume that all of this is minutes. Let's put units to these values. Time spent driving to work or something like that. Or time spent for a bathroom break, quote unquote. Right? Some of you are going for bathroom breaks. And I know the times, guys. Like the furthest fountain in the gym, from there to here, it's probably going to take you like 4 minutes. So 5, let's say, if it takes you a little longer, if there's a lineup. But anyways, let's assume these are like the breaks students take, right? What's the arithmetic mean? That's the regular mean. So make sure you have in your study sheet, if that throws you off that word, just say that's like the regular average. Okay? So we do it this way. We add up everything. We add up all of these, and how many values are we talking about? 2, 4, 6, 7, right? And when you add it all up, you get 55. If you divide it, you get 7.86 minutes is the average bathroom break students take in this particular class. Okay? Identify any outliers, then calculate the trimmed mean. Let's talk about the outliers. Are there outliers here? I think I would say, let's arrange them once. 3, 4, 5. So 3, 4, 5, and then 6. Sorry, yeah, 8. 20. So 1, 2, 3, 4, 5, 6, 7. Okay, good. Can you see that there's an outlier here? This one, right? So this is my outlier. Upper outlier. I can hear the flapping of a butterfly across the field. Anyways, upper outlier is this one, right? When you trim mean, I'm going to call this the trimmed mean. We're going to cross out 2 numbers. So for the trimmed mean, you must cut one of the lowest and one of the highest. And now you have a choice. Because I already calculated the 55, I'm just going to go 55 minus 3. I'm going to take away the 3, and I'm going to take away the 20. Instead of adding what remains, for me it's easier to subtract. And how many values are left now? You used to have 7, now you have 5, right? So 1, 2, 3, 4, 5. Double check, just make sure you do this right. And you get 32 over 5. Before we calculate, I want you to, don't do the math just yet. Go ahead. Just make sure it's not 20 minutes, okay? What do you think is going to happen to my mean if I trim it? You have an upper outlier, correct? So right now there's somebody pulling, like this one is pulling the average up. If I remove that one, do you think my answer is going to be lower than this? Yeah, it's going to be lower. That's what I expect to happen. So let's see what actually happens. I pretend to type it into my calculator. 6.4 minutes. Is that not what you got? Yeah, that's what I get. 6.4 minutes, so it dropped. Okay, so trimmed mean is lower because yeah, bless you. We removed the upper outlier. Yes, I know what you're saying, Mr. Erickson. We also removed the lower one, but the lower one was not an outlier. This one was. So when you remove the outlier is an upper one, then you expect it to go down, okay? Explain the difference. Why can't you just remove the outlier? Because now you're biased too much towards removing just the highest. You kind of want to like balance it out. So let's say a student comes over and says, Mr. Dirksen, can you drop my lowest mark on on all tests? Can you drop the lowest? So I only drop the lowest. Maybe we should also drop the highest, right? To kind of find like a compromise. Because if you're just removing the upper, it was still a value that you included at one point, so you kind of want to even it out. So that's the definition of trimmed mean. Okay. So explain the difference between the arithmetic mean and the trimmed mean. I'll give you a short and sweet answer to this one. The arithmetic mean is skewed or biased because it included, right, or includes all values, including outliers, or outliers as well, probably. Should I use that? Okay. Versus the trimmed mean, it's a better representation of what actually happened as it removes bias. In other words, the outlier or outliers. And I'll give you a note on the previous page because I believe that you should be able to pick the outliers and then trim it accordingly. So what if you had two outliers on the upper one, like that AC we just did earlier? Over here. I'm just going to bring this up here for 1 second. Finish it. I can bring it back anyways if you. So earlier with the AC we had two outliers on the upper end, correct? 48 and 50. How would you trim this one? If there are two outliers, you would go trim, trim, right? And what would you do on the lower end? Trim, trim. You gotta take one from each side. As you're trimming outliers, you gotta take, for as many outliers as you have on the upper, you also need to remove values from the lower. Okay, and I emailed the province 2 days ago asking about this. They will always tell you how many to remove in general. Like if it's more than one that you need to remove from either end, they will tell you. Because I was always a bit worried about that. So I'm going to say, you know what? I will do it right here on page 32. I will just do it right here because otherwise I will run out of space here. Note. I will just say you will be told, right? You will be told to remove more than one value from each end if necessary. That's a doctor's note right there, eh? Can't read that, Mr. Erickson. Anyways, so what am I saying with this? If the province says calculate the trimmed mean, what are we going to assume? How many are we removing from either end? One from either end. If they want you to remove more than one from either end, they will tell you. They'll say remove the lowest two and the highest two. It's such a giveaway, guys. Like, you can't even get that one wrong. Like, they will be very obvious about that. And when we go over old exams, then you'll see it, okay? At this point, I would like you to try. I have some more to say, but I think you're done listening to me for now. 32 to 36. I'm just going to say 32 to 36, even though we did 32 already. The key goes all the way to 36. Please use class time to try. You will come across some negatives and things like that. I will give you a little bit of a heads up here. This one, for example, on page 34, you've got negatives, so you've got to be comfortable with that. Your outlier may be on the low end or on the high end. You got to watch out, okay? So I'll just let you go through it, and I'll post a key, and you check, and hopefully that's enough for you to get by for now.